Picture yourself standing in Florence. The year is 1425. The streets below you are alive with chaos. Merchants shouting their wares, merchants carrying bolts of cloth, women with water jars balanced on their heads, children weaving between the narrow houses. This is a city that breathes, a city that never stops moving. But if you look up, if you simply lift your eyes above the rooftops and the towers and the endless crowd below you, you'll see something that commands every ounce of your attention. You'll see the cathedral. And when you look at it, something catches in your throat. Because this isn't just a building, this is white and green marble that gleams in the sunlight. This is wooden scaffolding climbing higher and higher into the sky, like a forest turned vertical. This is noise. This is ambition. This is a city announcing itself to the world. But there's something else. Something that every person in Florence sees when they look at that cathedral. Something that fills them with both wonder and dread. There's a hole. It's not small. It's not a crack or a missing piece or something you might ignore if you didn't want to think about it. This is a vast octagonal opening. It gapes open like a mouth waiting to speak. It's a void where something magnificent should be. And everyone in Florence knows it. Everyone stares at it, everyone whispers about it, because that hole is waiting for something impossible. It's waiting for a dome. Not just any dome. A dome so massive that no one living has ever built anything like it. A dome that will be visible from miles away. A dome that will tell every other city in Italy, Florence is not like you. Florence is greater. Years earlier, Florence decided it wanted this cathedral. Not wanted, needed. This was a city that understood power. This was a city of bankers and merchants and families so wealthy, they could afford to think bigger than anyone else. The Medici, the wool traders, the people who controlled the money and therefore controlled the world. And they decided that their cathedral would be unlike anything that had ever existed. So they started building. And for decades, architects and workers and craftsmen labored to create this marvel. They built the marble walls. They built the intricate floor. They built the drum at the top where the dome would eventually rise. But here's the problem that keeps everyone awake at night. Here's the thing that makes the Opera del Duomo gather in their chambers and argue until their voices grow hoarse. No one knows how to build a dome this large. It's easy to build a dome over a small space. You've seen them before. Churches across Italy have them. You build temporary wooden scaffolding underneath. You shape your bricks or stone to follow the curve, and eventually you have a dome. It's proven, it's traditional, it works. But this isn't a small dome. This dome would need to cover an octagonal opening so vast that if you tried to use the traditional wooden scaffolding method, you'd need to cut down entire forests. You'd need the timber resources of half of Tuscany. The cost would be astronomical. The logistics would be nightmarish. And here's the part that really worries people. No one is even sure that much wood could hold the weight. The structure might collapse, the dome might fall. And when it falls, it won't fall quietly. The entire city will see it. Every person in Florence will witness their city's greatest ambition crumble into dust. So the Opera del Duomo makes a decision. They call for solutions. They put out the word. They say to every architect, every builder, every engineer, every person who thinks they might have an answer, tell us how you would do this. Tell us your method. Show us your vision. And something remarkable happens. Ideas pour in. Some are wild. Some are desperate. Some suggest using the traditional wooden method anyway. Consequences be damned. Some suggest designs so strange and complicated that no one can even understand them. There are arguments. There's pride. There's politics. Different families want different solutions. Different guilds fight for their own interests. The city is fractured over this question. And in the middle of this chaos, this confusion, this pressure cooker of ambition and fear and civic pride, a man steps forward. His name is Filippo Brunelleschi. Now, he's not the obvious choice. He's not the oldest architect. He's not the most famous. He's not the one everyone would have predicted would win this commission. He doesn't come from an established family of builders. He's not even primarily known as an architect. He studied sculpture. He studied mathematics. He studied the buildings of ancient Rome, walking their ruins and understanding how they were constructed, learning their secrets. He's an observer. He's a thinker. He's an inventor. And most importantly, he doesn't think like everyone else. When Brunelleschi looks at that impossible void, he doesn't see an engineering problem that fits neatly into the solutions everyone already knows. He sees a puzzle. He sees something that requires a completely different approach. He comes to the Opera del Duomo with something extraordinary. It's not just a drawing. It's not just a beautiful vision of what the finished dome should look like. Any architect could do that. What he brings is something far more valuable. He brings a method. He brings a way to build the dome that doesn't require a forest of timber. He brings a way to build where the structure supports itself as it climbs. He brings a way to defy gravity itself, not by fighting it, but by working with it, by understanding it, by designing something so elegant that it holds itself together through the sheer logic of its own geometry. Picture this. Imagine you're sitting in a chamber with the most powerful people in Florence. You have millions of florins at stake. You have the reputation of your city on the line. You have architects and engineers presenting different proposals. Some say use the wooden method no matter what it costs. Some say it's impossible and we should just close the opening and call it a design feature. And then Brunelleschi presents his vision. He doesn't promise something simple. He promises something that sounds like madness. He says you can build this dome with a double shell, 2 layers connected by ribs, the inner shell and the outer shell tied together. He explains how the geometry will work, how each brick will support the next, how the structure will climb higher and higher, supporting its own weight as it goes. No massive wooden scaffold underneath. No need to cut down entire forests, just bricks and stone and mathematics and precision. It's audacious. It's almost impossible to believe. But it answers every question that keeps you awake. How do you build a dome this large? With a double shell that's lighter but stronger than a single massive shell? How do you keep it from collapsing? With ribs that distribute the weight and geometry that's been carefully calculated to support itself? How do you lift the materials? With specialized machines that use pulleys and leverage to make the impossible possible? How do you control the geometry? With discipline and measurement and inspection at every single step? How do you stop the structure from pushing itself apart? With chains. Structural chains that act like tension bands holding the entire dome together. You can see it in their faces. The members of the Opera del Duomo. They're terrified, they're skeptical, but they're also seeing something. They're seeing a solution that actually makes sense. They're seeing a man who has thought this through. They're seeing someone who isn't just dreaming, he's engineering. And so they make a decision, they choose Brunelleschi. It's not unanimous. There are voices of doubt. There are people who think it will fail. There are people who want the safer, traditional approach. But the weight of evidence, the clarity of his thinking, the fact that he can answer every single objection with a coherent response, wins the day. And so, in the year 1420, the work begins. The first bricks are laid in the summer of that year. It's hot. It's humid. The workers start slow. They're testing the method. They're watching to see if this idea that sounds impossible on paper will actually work in reality. And something miraculous happens. It works. The bricks settle into place exactly as Brunelleschi predicted. The geometry holds. The structure supports itself. Day after day, week after week, the dome begins to rise. By the time we reach 1425, 5 years into the project, the dome is visibly climbing. Anyone in Florence who looks up can see it. The curve is emerging. The shape is defining itself. And something else is becoming clear. This isn't going to fail, but the work is far from over. Imagine the building site in 1425. It's not a single project. It's an entire industry built around this cathedral. There are stone yards. There are piles of bricks stacked higher than a man. There are ropes coiled like sleeping snakes. There are wooden cranes and hoisting machines that look almost alive when they move. There's dust everywhere. The kind of dust that gets into your eyes and your mouth and your lungs. There's lime being mixed into mortar. There are carts arriving constantly with new materials and leaving with debris. And there's noise. So much noise. The sound of dozens of hammers hitting stone. The sound of shovels scraping against mortar. The sound of rope creaking as a load is lifted. The shouts of workers calling to each other across the distances. The creak of wooden scaffolding swaying slightly in the wind. The sound of hundreds of people working in perfect synchronization. Each one knowing their role. Each one playing their part in something far larger than themselves. The dome is not being built from the ground. That changes everything about how you have to think about this work. The drum of the cathedral is already high above the streets of Florence. When you climb to the top, when you finally reach the working level where the dome is being constructed, the city below looks like a map. The people look like insects. The wind is stronger up here. The danger is more immediate. Every mistake is expensive. Every fall is fatal. Before any brick is laid, before any work can begin, you need precision. You need geometry. The dome isn't a simple curve. It's octagonal. It has 8 sections like 8 segments of an orange or 8 sails of a ship. Each section is defined by ribs. Major ribs that create the main structure. Smaller ribs that add additional support. Everything must be exact because small errors at the base become massive errors at the top. The master masons understand this. They check, they measure, they remeasure, they inspect. Everything is verified. Brunelleschi himself inspects the work constantly. Because this is the test. This is where theory meets reality. This is where his promise either holds or breaks. And so the work continues. The brickwork follows a specific pattern. It's often described as herringbone. The bricks are laid at angles that lock them together. This isn't just decorative. This is essential. Because the dome is steep, the bricks want to slide. Gravity pulls at them. They want to slip downward. The herringbone pattern keeps them locked. Each brick holds the next one in place. The forces flow downward through the pattern. It's brilliant because it's simple. It's brilliant because it solves a problem that could otherwise destroy the entire project. Picture a workday. The sun rises over the Arno. The mist rises from the river. Men start arriving at the worksite. Some have been doing this for years, some are newer. But all of them understand what's at stake. The master mason checks the previous day's work. He looks for any signs of problems, any cracks, any deviation, any hint that something is going wrong. The toolsmith makes sure all the hammers and chisels and trowels are ready to go. Ropes are checked for frays. Pulleys are inspected. Nothing can fail, not up here. Failure means death. The mortar is mixed, constant. There's a man whose job is just to mix mortar all day. Lime and sand and water mixed to the exact consistency needed. Too thick and it won't work. Too thin and it won't hold. The balance is critical. The first load of bricks is lifted. The pulleys creak, the rope strains. Slowly, slowly, a basket of bricks rises into the air. It takes time. There's no hurrying this. The workers guide the load. They call out. They signal when to stop. The basket settles into place on the structure, and the laying begins. A brick is pressed into mortar. Another brick follows. Then another. The pattern is maintained. The line is kept straight. The angles are preserved, hour after hour, brick after brick. The dome grows by inches every day, by feet every week, by meters every month. But there's something else happening that you don't see from the street. Inside the dome, as the 2 shells are being constructed, as they're separated by carefully designed ribs, there's space being created. That space isn't empty. It will become passageways. It will have stairs. It will be part of the structure. But as the dome rises higher and higher, as the weight increases, as the outward pressure builds, these internal spaces become critical. They become the arteries of the structure. They're where the forces flow. They're where the logic of the design is proven true or false. The double shell design is working. The ribs are holding. The weight is distributed. The geometry is correct. Everything that Brunelleschi promised is coming true. But the work is relentless. There are seasons. Winter comes and the cold makes the mortar set slowly. Rain comes and the work has to pause. Summer comes and the heat makes the mortar set too quickly, and you have to adjust your technique. Wind comes, and it's dangerous to work on exposed scaffolding. The schedule has to flex with the seasons, while the discipline of the work never wavers. There are structural chains being incorporated into the dome. These are internal reinforcements that act like tension bands. They're wrapped around the structure to resist the outward push that the dome naturally creates. A dome wants to expand. The chains hold it together. This is medieval engineering at its finest. This is understanding forces that you can't see and designing for them anyway. The machinery is working as Brunelleschi designed it. Wooden frameworks with gears and pulleys and mechanical advantage systems that allow men and oxen to lift loads that should be impossible to lift. Slowly the loads rise, one basket of bricks at a time, one block of stone at a time. The machines become the arteries of the construction. Without them, nothing moves. With them, the impossible becomes possible. By 1425, 5 years in, the city of Florence has made a choice that is being validated every single day. The dome is real. It's not a theory anymore. It's not an idea. It's not a beautiful drawing. It's stone and brick and mortar climbing higher into the sky. It's proof that sometimes the person who thinks differently is the person who solves what everyone else said was impossible. Brunelleschi walks the scaffolding. He watches the work. He adjusts when needed. But mostly he watches as his vision becomes real. As men who didn't invent this design, who didn't study mathematics the way he did, who learned their craft through apprenticeship and repetition, take his vision and make it physical. The workers don't know they're making history. They don't think about how this will be remembered. They think about completing their section before the afternoon rain comes. They think about not dropping a load on someone's head. They think about going home to their families. But what they're doing is extraordinary. They're building something that will stand for centuries. They're proving that impossibility is often just a failure of imagination. They're showing that when you have a clear vision, when you have a method that makes sense, when you have the courage to try something no one has tried before, you can achieve things that seem impossible. The dome is rising, day by day, brick by brick, higher and higher above the city of Florence. And every person who sees it knows they're witnessing something that will last long after they're gone. The construction continues through 1425 and beyond. The dome will eventually be completed in 1436, 16 years from the first brick to the final stone. 16 years to build something that changes not just Florence, but the entire conversation about what humans can build and what they can accomplish. But in this moment, in 1425, we're in the middle of the story. The impossible has been proven possible. The structure is holding. The method is working. And the dome continues its climb toward the sky, carrying with it the ambitions of an entire city, the genius of one man, and the countless hands of workers who never expected to be part of something so great.